Today we're going to talk about independent and dependent variables. We're going to look at it in a variety of ways using graphs, using tables, and sometimes you might just have clauses as well where they just state a statement and you have to pick the independent and dependent variable. So we're going to look at this first part right here. On your worksheet, make sure that you find the same page that I'm on, and we're going to go through. So it says identify independent and dependent quantities in a graph. And if you look over here, I always like to look at the graph first. I see it says Macy's earnings. Okay, we have a Y and an X-axis. The X-axis is the number of days worked. They're counting by ones. And the Y-axis is dollars earned. And again, they are counting by ones. You also notice you have some coordinate points plotted. They look like they form a straight line, so that's interesting. Not every time when you have coordinate points will they form a straight line. But when they do, that usually means there's a relationship between the two things. So that's why we want to look at that. It says Macy earns the same amount each day for sweeping the floor. The graph shows her earnings for working days 0, 1, 2, 3, and 4. So right there is a point. Macy's earnings depend on how many hours she works. So the number of days worked, X, is independent quantity. Please underline that. Number of days, X, independent quantity. The corresponding number of dollars earned, Y, is the dependent quantity. Okay, so the independent quantity is the thing that's happening or that controls everything, and the dependent quantity depends on what happens in the independent. So if she doesn't work, she doesn't earn any money, but every day she works, she earns a little bit more money. So the dollars depends on number of days she works. Okay, that was an example of a graph. Here is, we're going to go down. We're going to do the example down here, the try it. So it says list the independent and dependent quantities in the graph. So if we look right here, we have Joe's lunch prices, we have number of days, and we have cost of lunches. Now, anytime they give you a graph, your independent is always going to be your X. So remember, X is the flat line, horizontal, X, so number of days, and Y is always your vertical line, or your Y-axis will give you your dependent, which is cost of lunches. And if we think about this, his cost of lunches depends on the number of days. I should put the word of right there. Cost of lunches. Okay, make sure you pause if you need to. Now we're going to look at what it looks like in a table. So identify independent and dependent quantities in a table. The table shows Macy's earnings for sweeping the floors for 0, 1, 2, 3, 4 days. So we just took over here what we had in a graph, and now it's in a table form. Number of days, they don't always put an X here, and they don't always put a Y here. Sometimes they could have put D for days, and they could have put total or T for total. So you have to not always assume there'll be an X and a Y. But 99% of the time, X is on top and Y is on bottom. So again, even looking at it in table form, the number of days that she works is up to her. So the number of days is the independent quantity. Okay, again, number of days. X is the independent. The number of dollars she earns depends on the days she works. So Y, that would be the dependent. Now we're going to take this a step farther and we're going to talk about writing an equation. Determine if the relationship in the table is additive or multiplicative. So are they adding each time or is she multiplying each time? In this case, for every day she works, she earns $3. So 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. That is our pattern. So we're multiplying by 3 each time. And that was our pattern. So we have a multiplicative relationship. Now the way that looks with multiplicative is your equation would be Y. Remember that was our total equals 3 times X, which was our days. So it basically is total dollars equals 3 times the days. And when we write that, it looks like this right here. Total was represented up here as Y equals 3, and days was represented by X. So it'd be Y equals 3 times X. Okay, let's try an example down here. says use the table to answer questions 2 and 3. So students' movie tickets, number of tickets is T, and you have 1, 2, 3, 4. The cost is C, and this is how much the tickets cost. And we're going to answer some information about this. So if I look right here, make this a little smaller because I want to have everything. There we go. If I look right here at this, the first thing it says is list the independent and dependent quantities in the table. Well, the one thing we know for sure is a number of tickets are going to be purchased, and depending on the number of tickets, you get a cost. So the independent is going to be the number of tickets, and the dependent will be the cost from the number of tickets you purchased. Okay, and it says write a rule that represents the relationship shown in the table. So first of all, we have to figure out if one ticket is $5.75, two tickets are $11.50. We have to figure out, are they multiplying by something? Well, I know from 1 to 575 would say we were multiplying by 575. So let's take 575 times 2 and see if that's the case. 2 times 7 is 14, plus 1 is 15. 2 times 5 is 10, plus 1 is 11. You have two numbers behind a decimal, so 1, 2. So 1150, yes. So each time it looks like we're multiplying by 575. So that means number of tickets equals 575 times the C. Okay, that is an incorrect setup, and I want to show you why. Number of tickets, if we took 1 right here, would equal 575 times 575. So that does not work for us because we know 575 times 575 does not equal 1. So when you're setting these up, you can always check to see if you have them right. So let's think back to what we had previously. If we think about how we can label, this would be our X, this would be our Y, because this one's independent and that one's dependent. We always start off with our dependent. So we actually want to have the cost equals the number of tickets times 575 times your ticket. So if I purchase one ticket, so 575 times 1, my cost would be 575. If I change that to 2 tickets, if I purchase 2 times 575, my cost would become 1150. So with using Y and X, our final answer would be this. Y equals 575 times X. And this would be your equation or your rule. Okay, now you can move on to your practice.